So today we talk about this O-Mopsi application. This O-Mopsi application is a game. It's a location-based game. And I don't know if anybody of you were there yesterday, but Lahari Sengupta, she had her PhD, okay, some people were. She had her PhD defense yesterday here in Science Park, and I was a co-supervisor. So her topic was this O-Mopsi game, but actually her main focus was the traveling salesman problem. So we will get into what the traveling salesman problem is, and also how it relates to O-Mopsi. But first I will have to give some kind of explanation of the website and the mobile applications. So the website is not really a game, it's more of a game platform. So the reason I say that is because you can play up to 158 games. So that's what this number here means. And there are game instances that you can play all over the world, but most of them are going to be in Europe, and most of them are going to be in Finland. Most of them are going to be in Joensuu. So I don't know if there is game in Kuopio, which is okay, Kuopion keskusta. So there is something in city center in Kuopio that may be played, but there are 71 games in Joensuu, so you can play more of them here. So each of these are games. And once you find one that you are willing to play, more or less you should choose it based on where you are at the moment. Once you find a game you like let's say you want to play the Noliaka game, then it's going to show you many things. First, a set of targets that you have to visit. So you have to physically go out, physically move, and find all of these targets that you see here as fast as you can. Now, this fast as you can is not really true. Fast relates to speed, but the order is not specified. So if you're really, really fast, but if your order is going to be all over the place, then you probably are not going to win, even if you're Usain Bolt or some other fast guy. So if we look at the results, we can see some things. I actually have no idea who played this. I didn't. But some people did, and some people finished in 26 minutes, in 1 hour 14 minutes. So the 1 hour 14 minutes, I can also see his track, this Jukka fellow. Seems to have taken some time, but anyway, you could see here that, for example, maybe if you play, you would choose to go here first, or so on. So it's not necessarily the best way. I don't know if Jukka's way is the best way here, but I can definitely see alternatives. I could see maybe other ways of doing it, and very likely other people have been trying some other way. It's very unlikely that everybody in the list is going to play the game in the same way. And I think to demonstrate that, I'm going to open another game. We have been going through to these SciFest events more or less every year. And this is where most of the players are coming from. So they are usually kids, but sometimes kids also with their parents. And they play these games on their phone, or sometimes we even lend them a device to try. But this year we haven't been because the application has just went so bad that it's causing complications. But if you check the database, you will see the SciFest in 2018 and 17, 16, 15 and so on. So we have been there ever since SciFest started every year, and usually these kind of playings were there. Otherwise, I have to say most of the players that are finishing any other game is probably one of us. Pasi is usually there, but okay, Pasi, Jukka usually play these games. I play sometimes, and Lahari plays sometimes, so Lahari is the one with the defense. Anyway, so we have here the time ranking, so time necessary to collect all the targets. And this is now a way, if you want to think about it, it actually doesn't say just about the speed, but it also says about the smartness of the person. So how smart was the person to choose the order of connecting the targets so that the time is minimized in both ways. So less distance, but also fast movement. Now, this is just fine, but the problem with only one scoring system is that you only get one winner. And Pasi and Jukka, they run marathons and all these kind of things, and it's enough to have just one guy there, like that, and then most likely you will not get any other people interested to play the games because you know you don't have a chance. So this is one issue. Like I gave this Usain Bolt example before. If he starts to play O-Mopsi, there is no point in competing anymore. Even if he maybe doesn't solve optimally, he may. He most likely is going to outrun everyone else. So that's the problem. And because of that, Lahari invented this second result system, where even though I am here in the last position, I am here in the best position. And this is because her job was to analyze how efficient did I connect the order of the targets. So to explain that, we would need to know what is the optimum order of visiting the targets. So in this case, this red line has been calculated on the computer. So it's calculated on the computer, it tried out all possible cases. This is the optimum way of connecting these targets, and I do have to attract attention that here there are more of them, there are 5. I can see them if I zoom in. So what is happening is that we have the two lists now. So I think I have to reload this, or maybe even reload the page. Somehow the other result list is not appearing anymore. Okay, and in the other result list we see, for instance, Pasi has one mismatch. So what this means is that this looks pretty okay. Okay, he started somewhere here. Okay. So most likely the mismatch is here. If I put also this optimum path, so he connected this to that, and so on, but the optimum path is here. So that's why it prints 1 point mismatch. Now, this is very minor issue here. it's not really a huge penalty, but it is different than what the algorithm says. And this is what Lohare reports here as a mismatch, whereas my path probably has that in good order. I'm not going to zoom in, but look at this mistake. So in my path I have this unexplained situation here. So what I did, I wanted to find this horse track. It was one of the targets. But the problem was that Pasi created this game, this Vappu game. And on Vappu, which is I believe 1st of May, there was a race happening at the horse track. And he put this location right in the middle of the horse track field. Now you see here the location is on the road. That's because he modified it after I played. But when I went there, I couldn't get the thing because horses were running around the place that I had to visit. So this relates very much to the maybe the gold mining game that you guys are doing, and I don't remember, but anyway, some projects that you guys are doing, accessibility of the targets. So if you are going to make some kind of game where you put things on the map, where do you put it so that you can get to it? He put it here. He even manually designed the game. He didn't think that that track is busy when I decide to play. So even human can make error there. So I actually tried as much as I could to get it. I couldn't get it. I continued the game. Then I went home and I hacked the database and I said I have to visit this target. So this
gold mining app, we defined an area around the treasure.
Yes.
So if the player comes into that area, then it marks it as if the player has collected the treasure.
I know, but still sometimes it's problematic, and I can tell you why. Because I know that you used the matching to roads function
yes.
to also allow for accessibility, but I can also say that it is going to match to a highway in case only highways are accessible.
Yes.
And in that kind of situation you will make this kind of circle, but this circle is going to be around a very busy highway.
Yeah, it could be possible.
And it's not a perfect solution, but it will work. So in general case, my example is just to point out the extreme, like what to expect, that it can fail. But yeah. Anyway, here also we have the circle. It's a 20-meter radius, but it's not visible. It's not visible on the map. You just know that when you are close to 20 meters, your phone application is going to make a sound and you're going to visit the target. It's going to say here 7 instead of 8, and you can go on. So that's how the application works. It still works and it's still on the Google Play Store. You can actually try it if you have an Android phone. It's probably the only thing from O-Mopsi that is still on some store for some reason. I don't know why it wasn't removed yet for the reasons I mentioned why the others were removed before. But anyway, speaking about this sound, so you get this ta-da when you visit and it goes away. You also get beeping noises while you're playing. As you are approaching the target, the beeping frequency, it gets higher and higher. So it's kind of like this metal detector thing, like your beep, 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 beep. And the reason for this is that you look at the map, you see where you want to go, but then it reduces the need to stare at your phone. So you can put the phone in your pocket and then you expect the beeps to get louder, to get more frequent. If at some point they get less frequent and you hear that, it means you made a mistake. Then you have to check your map again. So this relates very well with safety of the players. When your player doesn't have to walk like this, it means that he's more aware of his surroundings. Yeah, so sound navigation is something that you can consider. We have several papers on this O-Mopsi, the O-Mopsi topic, and there is one journal paper describing the whole O-Mopsi system, and many things like this could be of interest to you. Okay, but let's talk more now about yeah, so it does show me that I have a good order, but this mistake is not taken into account now anymore. So it's none of the systems that we have here for the scoring explain all the behaviors that are happening there. But speaking about this optimum path, so the traveling salesman problem that gives you that if you solve it gives you the optimum path, this is a very computationally expensive problem. It's a hard problem, it's an NP hard problem. And to know the optimum, there is not really a way to avoid exponential work. Like if you're looking for optimum, you cannot avoid exponential work. Having said that, it's not a direct exponential function that looks something like maybe e to the n, where n would be the number of nodes. There are many algorithms out there that can reduce this number of nodes, this value, this exponent, significantly. So if you think about it, like, okay, I'm going to open a second page, the TSP page, where I can load the same games again, or maybe even other games. And here on the top I have many different algorithms that we can test and see how they work. But let's see if we find one that is somehow more targets. Okay, so this this Sci-Fest game has 21 targets. So there are different kind of algorithms up here. For example, there is this branch and bound algorithm. I hope it still works. The idea is it's now it should output the optimum. So this is now going to be the optimum order for visiting these 21 targets. Okay. But if you would plug this in with whatever constant value for the base here, let's say 2 to the 21, this would be a huge number of steps that you need to do. So not like that. Okay, so is it really like this much? I guess so. Okay, but this is actually a mistake. It's not 2 to the 21 because to find out all the possibilities, it's yeah, I made a mistake. This is actually 21 factorial. Yeah, sorry about that. So this is 21 factorial because you can have permutations here. So you can start at any of the 21 targets. So you have 21 choices for the first target, then you have 20 choices for the second target in each case, then you have 19 choices and so on. So this becomes 21 factorial, and 21 factorial is a much bigger number than that. And if you assume that, let's say, your computer can do 1 million operations per second, or okay, let's give it more, 1 billion operations per second, then that still means this many seconds, which means this many minutes, and it means this many hours, and it means this many days. But I got the response much faster than this, so this algorithm that I pressed now, even though it gave me the optimum, I didn't wait this many days to get the response for it trying all the possible combinations. So it actually does some tricks, and I wonder if I have some, I think I have some tool for this. Okay, I have some kind of tool for this, but I don't remember exactly how it works. But more or less the brute force version of the algorithm looks like this. So this animation now shows how the algorithm solves all the possible 6 factorial permutations in this case. So all of the different variants are tried, and then the response is the one that looks like this gray line here. But then there are some observations that you can make. For example, let's say that you are starting with some path. You are starting, for example, with the path that looks like, I don't know, something like this. And this path has a length of 30 units, whatever the units are. And then at some point, you try to construct new paths into the system. I mean, you try them one by one. And at some point, you start to try starting at D, going to C, going to A, going to F, and now you still have to combine all the other things. The problem is that this red path here is already bigger than a full solution that I already have. So I don't need to try now to go to B to E, or to E to B, or to any other nodes if I would have more of them. So this is what happens in this variant of the algorithm here. So in this one, it skips situations where it makes no sense to continue, because we have a mathematical bound that it would be impossible to exceed a solution that we find so far. So out of the total of 720, we needed to process just 599. Now, there are more sophisticated bounds here that you can calculate. Some of them go into much depth, but I don't know if you are interested to know about this, and it's not that related to the course. But in this best case, it only did 117 out of the 720 operations. And of course, this will have a bigger impact when you have more nodes. Like now we have 10 factorial. So out of the 3.5 million of the operations is probably going to stop much faster. If you look at the gray area, it already kind of looks like some decent solution. It's not very bad. And it ended after 2,000 operations only instead of 3 million. There are much better algorithms than this, but you can see now some red lines here. They are all related to how these other bounds are calculated. But what you should know here is just that there are stronger and stronger bounds that you can create, similar to the previous one that I explained. And you can prove mathematically that there is no point to continue the search in a direction. The better you are at math, the better you can do these bounds, and your algorithms can just skip steps without missing on the optimum. So that is what is happening, and what lowers the complexity from n factorial to something else. What is the something else? I don't know exactly, but it could be something like n minus 10 factorial, for instance. Or it could be something like n divided by 2 factorial, for instance. I don't know exactly. I haven't studied these bounds so much in depth. But the idea is that complexity is measured in terms of n and constants are removed, so complexity doesn't change. It still stays as an exponential time complexity, but these values do affect execution time significantly. So this means that this algorithm, even though I'm going to go to n equals to 50 or something, I wouldn't expect it to finish today anymore, because it still goes in an exponential way, even though solutions like this 21 size become now realistic if we compare to this number of days that we estimated it should take on a decent computer. Beforehand it just takes few seconds. There are other algorithms here as well that are doing optimization, but not all of them solve the optimum. For example, we have here some greedy implementation. You can see it looks quite different than the red one. Something called ant colony optimization. So this is a swarm intelligence algorithm. It tries to simulate ants that are moving from one target to the other, always keeping the best. Ants have this property that they leave so-called pheromone trails. So they leave some kind of trail that the other ants can smell that, okay, there have been other ants coming here. And what is happening is that the more ants move in a surrounding area, the more these trails, if they are good trails, are going to be emphasized. So it's an algorithm inspired by nature, and it tends to work reasonably well, but maybe not necessarily giving you the optimum solution. Then again, how much is it going to be different? How important is, in this case, 40 meters? I don't know. This is depending very much on the application. I have to say that the traveling salesman problem is a problem that applies everywhere. It applies in nature, it applies in our jobs when you have to visit places. It applies in manufacturing. For example, if you open now my laptop here, you're going to find this kind of circuit board inside. And this circuit board has many holes in it. It has many holes and many solderings and so on. So the holes are drilled by a mechanic drill. And this mechanic drill can move, for example, like this, and then go back, and then go back. Or it could actually try to solve the traveling salesman problem. Something like that. And of course now, if you're going to move like in the first variant, it's going to take more time to do the drilling. If you're going to do this drill for billions of things, instead of lasting 1 minute is going to last 1 minute multiplied by a billion of objects, or how many you have. But if the original 1 minute becomes half a minute due to an optimum order, then your overall time gets halved. And that means money, that means less engine wear that moves the mechanical arm. You can model this as the classical variant of the traveling salesman problem. So the classical variant is you must connect all the targets, but also return to the starting point. Or you can model it as the open loop variant, which is what Lahari studied, where you don't have to return to the starting point. This has the same application in the case of drilling holes. You just drill the holes in this order, and then the next leg changes, so a new one comes, your drill is at the end point, you can then move your drill in reverse order, and you don't have to move the drill anymore. So these kind of small tricks affect everything, but I just want to point out that this application is not just us playing around, it's a very, very important application affecting many areas. Okay, now going back to O-Mopsi. So we do have algorithms that complete that solve this problem in optimal case and almost real time, like few seconds. So we need the optimum because we want to compare the people's progress. Were they able to solve the game efficiently and or not? So we don't tell them how to visit the targets in the proper order. That would be solving the game for them. But we do need a reference to compare, like how good somebody moves, and that's why we need it in the first place. But then what Lahari did, and I find it really interesting, is that she studied how people play. So this is, I think, much more interesting than the algorithms, because people tend to have different playing patterns. And and what Lahari noticed is that it's very, this problem is not very easy to solve by people in some cases, but it is quite easy to solve in some other cases. For instance, look at this case. I think everybody in this room would know to say the solution for this without having too much doubts. And I could argue that you could solve this even if I put 1,000,000 points. But if they would keep somehow this kind of linear pattern here, you probably wouldn't have much doubts how to connect them, because it's obvious. I mean, people look at this and say, it's obvious, they are in a line, this is not a problem. But computer wouldn't know this. I mean, computer would still have to try all the possible things, and the computer actually will start at A, which is here, and then move to B, and then move to C, D, E, and F, and this will be his first try. So you can see that computer would use quite many things. So what Lahari noticed is a relationship between the human's ability to solve these games and something called the minimum spanning tree of a set of nodes. So the minimum spanning tree is this. It's not a linear pattern. It can be a linear pattern. Like now, the minimum spanning tree in this case is equal to the TSP, to the traveling salesman path solution. But if I move a little bit like this, they are not equal anymore. So what the minimum spanning tree is, the way that you can connect all of them, the smallest way to connect all of them, but you can have branches. So branches can appear here, but this doesn't work for delivery purposes or things like that, because to go on this path you would have to go back here, and this extra path is counted twice, so it wouldn't work. You probably went, some of you probably went to DAA, and I don't know if this was studied this year, but Christofides' algorithm is handling these shortcuts at some stage. Anyway, so what Lahari noticed is that if your layout has these kind of knots here, the more knots it has, the more difficult it is for the human to solve the layout. You can see already now in this case that maybe now the solution is not so obvious anymore. I mean, I would connect maybe like this. Okay, I think the red is probably longer, but okay, this other one becomes also some kind of, some alternative, and it needs just a little bit of change when you start having the knots, and then you start having doubts, okay, which one is the order. And And in general, the more of these nodes that appear in the configuration, the more people start to have doubts and to think, okay, I fix it in this place like this, but how does my choice affect the other part now? And then you have two things to worry about. It's very hard to explain what people are thinking when solving the problem, but Lahari noticed strong correlation between ability of people to solve the game optimally and the number of these branching areas, these knots as she calls them. Yeah, so in this case, the optimum solution apparently looks like this. It even has some cases where it looks a little questionable, like here. I mean, the reason I say it's questionable is because this one goes there and then somehow comes back, but alternative would be to go first to D and then to M, and then you still have to come back, so you see that it wouldn't really change very much. So one of her paper was about this topic. How do people understand this problem? How do computers handle it in a different way? And this is an important problem to study, not just because of the two examples I gave before, but you solve it on a daily basis. So let's say that now you have to go to some other course, you have to go to lunch at some point, and maybe go shopping before you go home. So you already have 4 targets that you should optimize somehow to visit. It's not anymore exactly the traveling salesman problem, it's maybe the vehicle routing problem or some kind of scheduling problem, because some of the places have specific time when you need to be there. but it's a variation of it. It's a very related problem to it. And the reason she found it interesting to study people playing this is to see if they have some common strategies and if people can be helped to become better at solving these, affecting their lives more or less. So you can see how a very, very small change in one node location can affect the overall solution, even though the MST still contains the same number of nodes here. It's just an indication that there it's something that it's affecting it. Okay. Now, there is very much manual work going into creating some of these games. We use data from O-Mopsi. So if somebody takes pictures, geotagged pictures of things in their O-Mopsi collections, they can be used to create games. So creating a game at the moment needs you to select manually some targets, to put together, to group them together, and to say this is a game, it's called like this, and so on. Many issues here as well, like many problems that you maybe wouldn't think about, but we know them. We have been dealing with them for a very long time. For example, you take a picture of something, of a building. Let's say you want to take a picture of Puyo in Kuopio, this big tower on top of the hill, 70 meters tall, and yeah. You probably don't go where Puyo is. You probably need to go maybe 100 meters away from the tower to be able to take its picture. So that means that the geolocation of the photo is not correct. It's not where you expect the person to be in when visiting the tower. So now the question becomes, do you want the person to visit the place where you took the picture from, or the tower? And people tend to expect they need to go to the tower to visit it there. So this is one issue. The location of the photo itself probably needs fine-tuning. And more often than not, if you are concerned about the game quality, you have to manually fine-tune it. So just snapping it to some road or doing some dirty fix can have unexpected behavior. So there needs to be in O-Mopsi some kind of a manual confirmation that this game is okay. We do have many methods that create automatically. There has been a master thesis from Anton, I think. You can find it in our pages. His whole thesis was about automatic game creation in O-Mopsi, and we have functions for doing that. But very often we have problems like indoor pictures become targets. Pictures of people maybe become targets. Distribution of the pictures. So I talked a little bit before here that okay. Bugs. I said before that maybe people are very, very good at playing layouts that look like this. Is there a point to make a game that looks like this in that case? I mean, of course you can make it, but this is not anymore a game where you have to do orienteering, where you have to find targets. It's just a game where you have to run from E to B as fast as possible. It's not anymore the same type of game. This doesn't mean it's an easier game, because we have two objectives here. You have to be smart and you also have to be fast, but in this case you just have to be fast. So when creating the game, you have to see where is data available, where is the available data, what kind of configuration you can extract a subset that is both appealing, reliable, accessible, and has some sorts of challenge for the players. So all of these things, they are discussed in the publication that we have. It's probably called O-Mopsi. Yeah, so this one, it talks about most of the things that I have talked about. Similarities to the classical orienteering game. The fact that the person has to figure out his path by himself. The types of targets. Then examples of some good targets or some bad targets, most likely. By the way, this is how the application looks on the mobile devices. At least this Android should be still testable, but we had it on everything. So this was Windows Phone. This was the Symbian. And this is the iOS. A little bit differences in each of them, but more or less they were handling the same type of, they were having the same type of interface. Some example here about how the sound navigation works, the frequencies that we used and the intervals where we played them on. Some of the games we tried to make them educational. So for example, here we had kids playing some kind of thing where they look for different tree species, but then when they are at the location they see also the name of that specific tree there. So idea is more or less that you learn something from the place. This could be made to use something else, like maybe statues for history or whatever. The issue about the photo of the place not being at the location of the target that you aim to visit. So more or less this paper covers all these things that I have mentioned before. So there's no really a way to take a picture of this building than from other side of the lake. So in that case, the person will go to the building, he sees the photo of that in his app, and then, oh no, I have to go where the geolocation is. So the creator of the game has to modify this location manually to avoid confusion. Okay. Many other things here if you are interested to know all the kind of things that can affect the game, but yeah. And some other features have been implemented by students. I don't know if they really work anymore, but let's try. So we had this kind of simulation here. Okay, So I'm selecting players from this list now, and the idea is you can play this game at any time you want, really. Unlike the classical orienteering, you can play it whenever you want because there is not somebody there bringing the points with this reader thing that you have to mark your location all the time. So because you can play them anytime you want, it was interesting to synchronize all the players. What would have happened if all the players are moving, are starting at the same time? Like how would the interaction look like? And in this case, this is amazing that this feature actually works. I haven't tested it for a very long time, and I don't remember who did it. It could be maybe Gentian or Anton, or anyway, somebody has documented this in their thesis. So yeah, this looks a little bit like when you look at these orienteering competitions, they have this GPS tracking on the people real time, and it shows this kind of interactive map there. So many of these small features are everywhere in O-Mopsi, and also on this page. Some algorithms have more options here. You can interact with them step by step, or yeah, apparently even okay. So it even emphasizes what it's doing on the map, even though it's quite tricky to understand what the next step is going to be. So yeah, it's unfortunately a combination of being a real application that you can play, and also this kind of statistical analysis, experimental page with some features that are more interesting to researchers, some features that are interesting to players. So it's probably one of the reasons why this is not as popular as Pokemon Go or whatever. Of course, the franchise is something that is very important. Like we will talk, I think, Friday about Pokemon Go. But the main idea, nobody knows about this. Everybody knew about the other one. Problems here, what I mentioned about the game creation. You need manual work, you need manual tuning, you need people working on this. You take a picture of a bench, say this one, this bench is not there anymore now. In the winter time they usually take the benches. So am I going to take all the benches away from the database in winter time, or am I going to put there some schedule when the bench is expected to be there, or how am I going to model the database? In Pokemon you have more or less artificial data. You do have the meeting points that are going to be, I mean, these Pokestops or gyms or whatever. There are some objects there, but it's not going to impact the gameplay too much if some construction work happens or so on. If something happens here, like the horse track example makes it inaccessible for me, then it's going to impact the score very much, and my happiness level, if I were to say. Here, this bench maybe is not so important because I'm anyway going to go to the location and get it. But if I'm going there and I'm looking for a bench and I don't find it, at some point I'm wondering, am I in the correct place or not? And then maybe I even go and look around, but afterwards, if I open the phone, I realize that, okay, I actually got the target, I just don't see the bench. So it does affect also playing time because it's supposed to be a competition. The reason for the photos is there, it's quite important, I think. So in your case, you don't have photos in your application. You just have locations that you have to visit. But like if I look at this game layout, I'm going to instantly recognize something. I know where this bench is supposed to be. I recognize where Vesico is. I recognize where the treetop, whatever thing is. I know where this mural is, and of course I know Science Park. This graffiti, by the way, is not here anymore. There is some graffiti.
Yes, like we plan to add the locations where the player has collected the treasures.
Oh, it is here. Sorry, I thought it's another. Sorry?
We are planning to add, as an upgradation, we would plan to add the images at the location where the player has collected the treasures.
Not all the applications need images there. For example, in Pokemon, they just use some kind of fancy 3D rotating stuffs or whatever to indicate the same type of objects. But the fact that I have images here, now they went away, okay? I don't look at them anymore. But I still remember that it was Vesico there. I remember the bench, I remember Science Park was there, the mural. I remember all of them. I don't have to look at my phone at all. I can play this game in my mind. So this is the benefit of the images. It's not, I can instantly recognize some things if they are in my hometown. If they are not in my hometown, they also help identify things. If you see a giant picture of a church, you're going to start looking for it even when you're 1 kilometer away. Maybe you can see it between the buildings or so on, and it's going to help you with the guidance. So it's not just a game about looking at the map or listening for the sound or whatever. It needs much more skills to behave. And if you can play this game by remembering the games, making some kind of mnemonic in your head of what is the order of playing, you will gain time that you would waste opening your phone, starting it again, panning the map, where am I now, these kind of things. So it impacts gameplay and many things. There are solid reasons for having the photos there. It becomes much less, much more different as a game if you remove the photos from there. Even though you can still play it and you can still get scores and everything else would work. But the overall feeling when playing the game changes. And this is something that is very important when you are building an application. You should not build an application and just test, does it pass the unit tests? Does it have bugs or glitches? You should try to feel, is it something you want to play? Ask people, is it something they want to play? Why not? And try to figure out what would be a good, isolate the target audience of people who would actually like to play this. I could say target audience for O-Mopsi could be, well, initially people who run a lot. Now we have also this ranking that gives you, maybe you become the best if you have a good order. So many people want to do exercise. So these exer games are a reason for them to go out. If you talk to people, many people say, I don't go anywhere if I don't have to go anywhere. It's a thing. Many people think like that. I only go out if I need to go somewhere. But if you want your name to be on the top of some list, then that is a need to do something extra, to go outside. And you don't have to be a fast runner to be on the top of a list. And if we make more lists, we actually have here some kind of, I forgot about this feature. But, okay, some kind of profile page where it says some things about me, like these badges or whatever. This was also an attempt, I think, from maybe Gentian's work. to make us more happy to use the application. So you get extra points if you create games in the system. You get extra points if you solve in a good order, and you have extra points here if you are actually the winner in terms of time. So trying somehow to make you feel more of a winner,
and that motivates you to go out and
I
search
think
for places.
I think it's a good assumption. And every time you are looking at the screen in Pokemon Go, you feel like a winner. So in O-Mopsi, okay, in O-Mopsi, if you get closer to a target, every step, you may not feel like a winner. If you already know that you have made some mistake in the past, you may start to feel like, might as well finish this, I'm not gonna win anyway. But in Pokemon Go, okay, there is a Psyduck or whatever creature there. One step closer to it means one step closer to getting it. It's gonna be there. They don't have the system that somebody else steals it before you, I think. I think these the creatures are independent by your screen. When you go there and you throw the ball, it's like, okay, maybe you fail to get it. Then you're like, damn, I failed. But the wind is this way, and it was moving somehow like that. I learned something. I think next time I can do it. Oh, I don't have balls anymore. Okay, I pay for it because I'm sure I can get it next time. So even though you fail, you learn something. You're closer to getting it. At least you think so. So our game has these issues. And of course, then at some point you're like, oh, come on, the place is inside this, it's closed, I can't get in after running so much. Uninstall. I mean, in Pokemon Go, it can happen sometimes. Like maybe, okay, it shows it on the river or whatever in a place where you don't have enough players. It happens rarely. They have quite good data infrastructure there. But still, when it happens, so what? It's next one is just there, across the street. So you don't lose the whole game and the whole effort you collected so far. When a Pokemon appears on the river, you don't lose all the Pokemon you collected today.
So there is some or the other thing to motivate the user.
This is more of a competitive. The other one has the collective motif that is emphasized more. Here also you are collecting things like how many games you played, how many whatever, so you have some collective motif, but in Pokemon Go you're always collecting, always collecting. So even if you don't fight with people or compete with other people, people like collecting stuff and somehow feel good about that.
Can I ask you one question?
Yeah.
This O-Mopsi app, is it like made with pure JavaScript and HTML, or
so all the mobile apps,
any
I mean here it's not using any framework, I think.
So it's plain JavaScript and HTML?
I think so. It may use some libraries. At least it uses jQuery. I can tell you that, but it's not really a framework.
I believe the code would be very complex now because it has a lot of stuff.
Oh yeah.
So it's very hard to maintain the code now.
It's very hard, but the main reason why we keep it this way, I have to say, it's because of you guys. I mean, every time some new student comes in and he wants to do something, he knows something else. You will get the student that knows Flask. You will get the student that knows React. You will get the student that knows, and then you have all these things like WordPress, Joomla, whatever, these things. And if we add all of these things as part of our system where a student comes in, stays for 2 months and then goes away, then you have a requirement for a specific framework there that other students must know if they want to continue that other student's job. So then what happens is that you have a new student, he tries to learn the framework, after 2 months he learns the framework, doesn't do anything but has to go away. So,
but we could do one thing, is that like we can use any of the JavaScript, basic JavaScript frameworks like React.js, AngularJS, because these frameworks, the frameworks are different. Maybe I would take time to adapt to that framework, but after 2 weeks of time, I would get to know about the framework and start working with it.
Yeah.
With my personal experience, like I have been working on different frameworks. It takes time to learn the framework, but the base is JavaScript. So
Yes, I know.
it just takes 1 or 2 weeks to get adapted with the framework.
It's true, and it should be done.
Yeah.
It should be done. If this is going to go commercial, this should be redesigned. I mean, you take the good features, redesign them, use a framework. The problem is in university environment, it doesn't work. And the reason, okay, many reasons, but think about what troubles we have now with the mobile apps. So the reason they are taken down from marketplace or they aren't installed is because the third-party APIs used there are obsolete, are getting old. They need new updates.
Yes.
When you compile with the new updates, you need to change the code. We don't have experts anymore. What happens with the frameworks is the same. Think about this Angular, Node.js. They get new versions all the time. Your students, your group,
every month they launch a new update in Node.js.
and sometimes it's a drastic update.
Yes.
Everything needs to be redesigned, or very big changes have to happen. I don't know these. These are just speculations. I don't trust what I'm saying. But I don't know. I mean, I also lost track of them since working at university, and that's also the reason why this VVD course was mostly about building from scratch the things. Also because I wanted you to brush up on the maths and
Yes.
Other things that I think are also very important. But the thing is, if you have a dedicated team and if you have money for making it in a commercial way, and if you have solid ideas, then you can choose a framework and you can do it wisely.
But then we need to keep on updating the framework.
But
the
that's what
framework,
you
it
do.
gets outdated very fast.
But that's what you do in a
Yes.
company. You
Mhm.
always maintain your app. Here, at the moment, the number of people working on O-Mopsi is 1. And it's a good thing. Usually it's 0 nowadays. So the thing is, if we would have a framework here, let's say Angular, it would mean that the one that is working on it now wouldn't know how to do it. It's not in his list of skills that he knows how to do it. So even though we have so few people working on it because we don't have funding, so they only do it for credits or things like that, it would drop even more because they wouldn't know the skills. So knowing JavaScript, adding jQuery, you would think it's nothing. But it depends about your skill. I somehow think you have good skills because I've seen your video this morning and I checked the code. So some people, when they hear it uses jQuery, a whole new world of things to learn, and not everybody is learning very quickly. For you, probably it's nothing because maybe you're familiar with it or whatever, or with similar things. So it's always easy to do something you know of, or you have an idea of.
And
But it limits our resources.
It comes more on the maintainability of the application. Once you use a framework, then always you need to update the code with the latest version of the framework. Because I can relate this very well. I worked on an application which was developed on Node.js 4.0, and every time I used to make any change in the application, I had to make sure that the version of syntaxes of JavaScript I'm using, it should match the version. So the Node.js 4.0, it was really outdated, and the current version which is running on right now, it's 11 version, Node.js 11.
Okay.
So every time I used to make the change in the application, it used to break because of the syntaxes I'm using in JavaScript. That's the problem with the frameworks. Like once you start using a framework, then you need to have a team which keeps on updating the code, doing the code migration.
Yeah, okay. That's true.
Yes.
I can also say one more thing about this, about using frameworks, is that sometimes I do accept students to do something using them. For example, well, some people use Flask for making interfaces in Python. And the problem is that sometimes the server is not happy with that. Like you will need to open some specific port or to do some specific configuration that starts conflicting with something else. So in some cases when you have these kind of, if you allow more tools, more things to appear, first of all, you need to involve UHA or system admin or somebody to make sure the server is okay, it's not going to be affected by them. And then what happens is that at some point UHA decides, okay, now PHP improves to, evolves to version 5 point something, and then some of these components just disappear, they won't be compatible anymore. So the more you allow this kind of freedom to choose the environment, the more things break and more things are hard to manage afterwards, when you don't have a team, especially.
Yes.
But yeah, so I know all the things you're saying. I encourage everyone to use libraries, use frameworks. It's the way to go because that's what everybody is doing, and it does much of the work for you if you are familiar with it. And it has been tested by many people and proven as a reliable source. You shouldn't reinvent the wheel ever. But in our case, it doesn't work. It causes many complications, and much of the features developed, started in some of these ways, just disappeared. They aren't functioning anymore. I don't know. I mean, my skills have dropped a lot. I mean, since I was developing maybe 8 years ago, I was a freelancer. I was a Flash developer.
Flash developer, yes.
So that says a lot. Flash.
Flash.
I was doing ActionScript.
Actually, it started with the, before JavaScript, the Flash language, scripting in Flash language, it was very famous.
Yeah, yeah.
My elder brother, he used to work in Flash like about 6 to 7 years back. And
Yeah.
then later on, the programmers who worked on Flash, they shifted on into the JavaScript frameworks.
Yeah, so when I was a freelancer, I worked on this. So this is a website that allows you to do video conferencing. I was the only developer.
And now it is like a big team who is taking care of this website.
I don't think so, because if you would look at the screenshots or whatever of the application here, it looks the same that I left it in. I don't know how the website looks anymore, but yeah. Anyway, I would have to.
They
check.
have it live. It means like they are earning some business out of it.
It's a business.
Yeah.
So it's a business. It's based in US, but Flash disappears next year. I mean, it's being stopped supported by browsers.
Yeah.
So I believe they have moved towards mobile platform meanwhile. But the thing is, from then to now, it's like I'm from prehistoric age. Like if I would tell what are the ways to do something.
But still, I guess like you would be pretty much very able to adapt with the frameworks right now, because once your basics of JavaScript and everything is strong, then it is very easier to get on the framework. It's not that difficult.
It is, yeah. I mean, it's easy to learn a framework if you know the basics.
Yes.
But I don't know how easy it is to get your mental state into the fact that this is going to be what you're going to do from now on. I mean, you're not going to improve anymore to learn more sophisticated things, more interesting algorithms, or develop new algorithms. What you're going to do from now on is learn framework and get ready for next month when the new framework comes, and learn that framework, and then learn the next framework, and
Those are
then the next
totally
framework.
separate areas.
So-
Using the utilities which are already available on the net and creating one
Yeah.
utility. So those are totally different two areas.
Yeah, but very good discussion, because this applies. It's the reason why O-Mopsi has bugs in many places. It's the reason why some inconsistencies, like things shouldn't be. Like, why is this here? Why is that there? I don't know, and if I would answer, I would probably find that some kind of, I don't know, left margin forgotten here or whatever. So these kind of things go away when you start to use components that have been provided for you, instead of trying to redesign them. This looks even darker than this, so I think it's a different component entirely. The shadow here is darker than here.
The
It's the same
also
as
would be
here.
CSS would be different for all these.
Well, yeah, but anyway, so
But
you
yes,
have
like,
very good points.
I can realize that I worked on frameworks, but I lost control on these mathematics and algorithms. Majorly because I get all the things ready-made, utilities and everything in Node.js, like packages already they are available, and I just need to download those packages and use those packages instead of creating one of my own.
Yes.
So if I use basic JavaScript, I would create one of my own, all these things,
Okay.
and use it. But if I use a framework, I would get all these stuffs ready-made
Yes.
as an API.
Well, that's how development these days works. So development is very different from studying algorithms or practicing math. Most of the websites today are quite simple. They are just push a button and show some result that is calculated already on the server. So more or less your development is just push a button, show the result. Push a button, show a result. You barely even have to write a for loop.
Yes.
I mean, yeah. And now your question should be, is that what you want to do, or do you want to get into computer science? There are pros and cons to all of the things.
Yes.
Some people like that, and I like that. I mean, I like to do things that are simple, or now I'm hinting to some things when I'm teaching or whatever. Like I do take some time and I do this kind of drawing icons or doing some kind of design work, or maybe sometimes I focus on design. Sometimes I work on the algorithms part. I think that it's a good idea to have a little bit about knowledge about all these things, but I wouldn't call myself a designer. I mean, I know in a company that, I mean, if you are going to be a designer, you're supposed to do very good quality stuff. If you're a tester, you're supposed to leave out very few bugs still remaining in the code, or not figuring out where it comes from.
But now the scope of testing field, it's like getting reduced. The team who used to take care of testing part, they are like getting in less numbers now, getting jobs, because nowadays developers, they themselves handle the testing by writing the unit
But
test
you know
cases.
why? Do you know why? Well, first of all, it's the unit testing, but the second reason is the frameworks.
Yeah.
I mean, much of the components are already tested, and the bugs that are appearing
Yes.
appearing less. So the number of testers are also reducing.
Like in my team, when I was working in a company, we didn't had any testers. We just had code. I had 3 developers working with
I
me.
would like to add a comment here. It depends on the structure of company.
Of course,
Company actually force the
Yes, yes.
testers or not.
Yes.
of course.
They should have enough budget to have
The
some separate
multinational
testing
companies, like the
for-
big companies, they had a team of like 25 testers, and they do have still now.
Of course, it depends very much, and it depends who is your target audience, how much budget you have. Are you supposed to do something novel research-wise or not? Because some companies may need research and development, R&D group there, a research team. But for normal applications, like I don't know, this kind of, if you make a website, you probably don't need a research team for that. But a simple website.
So now there is a framework for testing also, a JavaScript framework.
For
Intern.js.
Sorry?
Intern.js, there's a framework.
I've never
Intern.js.
heard, but I trust
So
you.
you need to develop a code to write automation script in JavaScript to test another code.
Mhm. Well,
So somehow you are getting into development stuff only.
yeah. Anyway, so if the company allows, then you are going to get all these specialized people in different parts. But even so, I think it's a very good idea to know what it takes to build some application, like in its fullest. So that's somehow the reason for your projects here. I want you to think about all the steps of making an application, because even if your job is going to be a back-end developer or whatever, and you don't care about the interface or design or anything, someday you may. Even if someday you start the company and then some of your employees say, oh, throwing a button, okay, 2 months. then you know that, no, it doesn't take 2 months. I can do it in 1 day. You can do it a bit better, but it shouldn't be more than 2 days. So knowing this kind of a simple thing.
Usually we hear this by a manager.
Yeah, but the manager should know these things.
Yeah.
So if the manager doesn't know,
He's a
then,
technical manager.
well, good manager. But in general, I mean, you wouldn't know otherwise. I mean, if you don't at least try a little bit to see what that is. And I think the courses here, I mean, in general, university is about learning things, not necessarily becoming successful with some application. So take it as a learning practice. Okay, very much discussion, and we missed also the break, but I think if you have more questions, I can answer, but otherwise we can stop. And I think some of you were asking before about showing some projects to me, so we can do that. But any questions? I hope these conversations were heard. I did check that the microphone is just here, so hopefully they are useful. And many of these things are subjective things, like they are not algorithms or things like that, but I think they are on the right track. So don't take everything we said for granted, but they are all problems that we are dealing with, and we don't know the best solution. Yeah. Okay. So if no questions, then see you on Wednesday.